So these are functions of the form. This is the one that I'm talking about. Y is equals to sine, the sine of what? Of theta, the sine of theta plus p. This is the function that I'm talking about. So that is the one that we didn't actually do. So one thing that you need to understand. Now let's speak about the effect of the parameters. The effect of the parameters. So remember, this is the only last part under the sine graph or sine function which I didn't teach. The effect of the parameters, right? So one thing that you need to understand is that the effect of P, we're going to speak mostly about the effect of this P here. You can write notes, the effect of P, but it's not a lot of notes. The effect of P on a sine function, on a sine function, the effect of P on a sine function is a what? Is a horizontal shift. Is a horizontal it's a horizontal shift. It's a horizontal shift. That is what that is called horizontal shift. That is called what? A phase shift. This horizontal shifting is called the phase shift. So if they're talking about a phase shift, from now you must have an understanding of what they're talking about. And then this phase shift, it shifts the graph. Shift or shifts the graph either in one of the two directions. Shift the graph in either one of the two. Shift the graph to the left. The left. Shift the graph to the left or to the right. So one thing that you must understand is that this P, this value of P, we consider it as what? As a phase shift. And then it can either move in either one of the two directions. It's either the graph moves to the left or the graph moves to the right. And then if you can understand that, I think you'll be now on the safe side. Number one, for P is what? For P is greater than 0 or P is bigger than 0. Then the graph of a sine function the graph of a sine function the graph of a sine function, what does it happen? The graph of a sine function shift to the left by P units. shifts to the left. Apologies for my handwriting, to the left. Shift to the left by P. Right, so those are some of the things that you must know. And then with regards to the other one, number 2, for P is less than 0, for P is less than 0, when you say P is less than 0, it simply means to say it's negative. The graph of a sine function graph of a sine function comma shifts to the right by P. Never make a mistake in this regard. If P is greater than 0, never say the graph of a sine function shift to the right. Is always the opposite. If P is greater than 0, anything that is greater than 0 is positive. The graph of a sine function shifts to the left by P units, right? And then, for an example, if P it's minus 60, it simply means to say it's going to move 60 units to the right. For P is less than 0, the graph of a sine function shifts to the right by P units. So those are some of the things that you must actually know with regards to that. And then maybe some of you will actually get confused. Let me show you how, or let me support that statement. Remember, we are speaking about the original curve of a sine function. By now, we should be able be in a position to basically understand what is a sine graph. P is greater than 0. The other one is P is less than 0. Then I'm going to consider that as our what? As our Cartesian plane, so that I can better explain this as well as this one right here. So if this is our Cartesian plane, as well as this one. So let's say this is our Cartesian plane. So we are taking it from the original curve of y is equals to sine x. So you now have an understanding that the sine function is going to be like this. That is a sine function, right? And then having this one, still a sine function. So let me just finish drawing this. I want to explain something that is very important here. So you must always look at the original graph of a sine function, how it moves. The other one is upside down, the other one. Remember, coming from the concept that I told you to say the sine function is going to be like this. It always start at 0, that is 90 and 1, 180 and 0, 270 negative 1, 316 0. Do you get to see that? So one thing that you need to understand is that you now knowing that this is the graph of y is equals to what? Y is equals to sine x. You must be in a position to be able to see the difference. So with regards to the statement, the two statements that I just wrote above, of me saying that for p is greater than 0, the graph of a sine function is shift to the left by p units. This basically this basically means to say, if you are now shifting that graph, now we're going to have the green graph for p is greater than 0, that is going to appear like this. get to see that when I have that graph there. And then with regards to the concept of us having known that is the shifting of the graph where p is less than 0, it basically means to say this one is going to be like what? It's going to be like this. You knowing the shifting part of the graph there, it helps you a lot not to actually struggle when plotting this graph. Just like that. So those are some of the things that you must actually know. So it actually depends on the knowledge that one will have mastered at that particular moment. Whenever what you can do for now, just understand that for p is greater than 0, the graph of a sine function shifts to the left by p units. Then for p is less than 0, the graph of a sine function shifts to the right by p units. And then these two graphs, you'll understand them much more better when now we have understood the concept of how basically we shift the graph. Any question? So now let me make an example and then we proceed. I'm going to make an example based on what I was explaining just now. Because they will actually say draw the following graph. So they are saying that the following function is having the restriction. It is having the restriction theta is less than or equals to 360 degrees or greater or equals to what? Negative 360 degrees. So that is the restriction that they actually give you, right? And then they say you must draw the graph. You must draw the graph of y. Y is equals to what? Y is equals to sine of theta minus 30 degrees. So you must draw this. That's number one. You must draw the graph of that function. Then on number two, you must actually find the what? The period. Then on number three, you must actually find the what? You must actually find the domain and the range. Domain and range. On number four, you must find what? The x and y intercepts. X and y intercepts. X and y intercepts. Then after the x and y intercept, lastly, they want the maximum and minimum turning points. Maximum and minimum turning points. Minimum turning points. So for you to answer the following questions, you can't answer them if you didn't draw the graph. So you must be able to draw that graph in order for you to be able to answer those questions. And then this is what you need to do. And then you must also be very careful. As you're drawing that graph, you must check the restriction given thereof. So it means to say, since they're saying from minus 360 to 360, you must either extend your graph from both ends. So that is 0 here, 90, 180, 270, 360. So use a rule. Myself, I don't have a rule. I can't use a rule on this platform, but use a rule: 0, 90, 180, 270, and then as well as 360. And then let's see, 90, 180, 217, 360. 270, 180, as well as 90. Then this one's the negative. And then another thing that you must know, since you're working with a sine graph, that's what I'm saying. You're gonna struggle if you don't know the mother graph of a sine function. You're gonna struggle in drawing the graph. So here we know that sine function, it's 1 and 1, unless if they give you a certain value that has to do with maybe the amplitude. Let's say they gave us 2, then it means to say we're gonna extend. But in this case, since it's just an invisible one of which they didn't write it, then I'm much more safer to draw that. Right. And one thing that you need to understand, in order for you to draw this graph accurately, so you can start by plotting the graph of y is equals to sine x, even if they didn't tell you to plot it. And then just because of now this is negative 30, I told you to say when it's negative 30, it simply means to say this graph is shifted 30 units to the right, if you were listening to enough. So it's kind of like you drawing the sine function. 0 and 0, let me show you. Or let me show you so that you don't struggle. 0 and 0, 90 and 1, we all know. 180 and 0, 270 and negative 1, 360 and 0. But we are not, okay, let me show you. This is the basic sine function. You all know it's like this. But we are not only concentrating on the positive side of the x-axis, just because of they're also telling us to say it must be from minus 360 to 360. This one that I just draw is from 0 to 360. Then you extend that. It means to say your other coordinate must be here. Other one must be here. Other one must be there. Other one must be there. So you continue joining the graph. So this is not the accurate graph for this function y is equals to sine of theta minus 30 degrees. The brown one is representing this equation. Y is equals to sine x. Why am I writing this? It's because of they gave us the yellow one that I need to, or let me not use yet. They want us to draw this graph of y. It's equals to the sine of what? Sine of theta minus 30 degrees. Right? And then, since we know that from the notes that I just showed you here, let's go back a bit. For p is less than 0, the graph of the sine function on number 2 shift to the right by p units. So p, you can actually see here that our p is negative 30. So it simply means to say that brown graph, since it represents the equation of a function y is equals to sine x, I'm going to move each and every coordinate 30 units to the right. Remember, I told you that is the opposite. If it's negative 30, you must move it 30 units to the right. Do you get to see that? So, me now moving the what? 30 units to 30 units to the right. What are we going to have? Simply means to say you're going to have the following graph. So you must have half of that. You must have half of that for you not to make a mistake. So the one for 360, it goes hand in hand with half of that. So it will be somewhere there. Should plot it accurately. So it's just that now it's going to be a bit challenging because I don't have a drawing, what do you call it? A drawing paper or a graph paper. So I'm just going to try my level best to actually help you with regards to that. Then it passes there. Then this one, half of that somewhere there. Then this one is somewhere there. Somewhere there. Then here it's somewhere there. Half of that is somewhere there. So do you see? You follow this point. You actually plot this point, see? Half of that. Then, okay, let me finish writing the coordinates, then we'll plot it after. Then here we are having a coordinate just right here where the graph is going to turn. Then do another one right there. Here we're having another one right here. And we're having here, then we're having another one right here on the half. Right. Then we're having another one just slightly below the turning point. Then there should be another one right here. So we start one. So you're gonna plot those green points. You're gonna plot those green points. Gonna join them. Gonna join them. Gonna join them. Gonna join them. Something like that. So you can actually see I tried my best with regards to doing that. It's a bit challenging. As long as if you don't have a coordinates, then it makes it to be a bit difficult. But I just tried. So the green one is represented by y is equals to what? The sine of theta minus theta. You guys, you are not gonna struggle in an exam because they will just give you an answer sheet that has a graph paper on it. So you might find that you see the green one that I just drew. They will actually draw the original one and then they need you to just translate or move it, right? Then it becomes much easy with regards to that. And then since now we are having the concept, we have now drawn the graph, which is that. And then now let's find the period. So the question, remember, it's specifically concentrating on the what? On the green graph. But if you want me to explain, or let me just write it there. Since I've just drawn the two graphs, let me write the period of the brown graph, which is representing the equation of the function y is equals to sine x. Then I'm going to also write the period of the green one so that you see the difference. With regards to the period, I'm going to write the period for both graphs. The domain and the range, I'm going to write the domain and the range of the two graphs, x-intercept and the y-intercept of the two graphs, maximum turning point as well as minimum turning points of the two graphs, so that you can actually have an understanding and see a difference. Because I wanted to write only of the green graph, but maybe some of you will get confused. Next. Okay, so here we're going to consider that as this graph of y is equals to sine x, which represent that sine theta or sine x, which represent that brown graph. Then this one is represented by the green graph, which is y is equals to what? The sine of theta minus what? Minus, that should be 30 degrees. It should be 30 degrees, right? And then with regards to that, now let's look at the period of both graphs. So remember, I showed you to say the period, it has the formula. So the period is 360 for both. So period here is going to be 360 degrees. Even this one, the period is going to be 360 degrees. When you speak about period, it's not guesswork. Period, it's the entire cycle of one wave. For you to be able to see and not get confused, you can see that the brown graph from 0 up until 360. This one, it's one wave, this one. It's one wave. Do you see? It's 360. You get to see that. So when they speak about the period, I've explained on the previous video. What do we mean with regards to that? If you don't understand, we'll encourage you to go to the previous one. And then now let's deal with the amplitude. Now let's deal with, that was the period, number one. And then here I'm just gonna write amplitude. Just gonna write the amplitude. So with regards to you now knowing the amplitude, I'm just gonna say amplitude. Write it. So if you want amplitude, if you want, you can just write it in a table form. I think it's still gonna be correct. So as to make your work to be much neat and easy, you can just draw a table in between. Sorry for that. You can use a ruler. I'm just trying to make sure that I accommodate all of you. So that is the amplitude. So with regards to the amplitude, what will be the amplitude of both graphs? The amplitude is 1. Also this one, the amplitude is 1. Remember, I told you to say the amplitude. There are two ways in which you can find it. You can just go to the graph or either one of the graphs. You check what is the amplitude. So if you check for the green graph, the distance from there up until there, this distance here, it's 1. Or the distance from here on the brown graph up until there, the amplitude is 1. Or you can just say maximum minus minimum divided by 2. Either one of those will still get the amplitude incorrect, of which the amplitude is 1 in that particular regard. Then we are done with the amplitude. Now we go to what? Now we go to number 3. So on number 3, they want what? They want the domain. Just gonna write here. Hope you are able to see. So with regards to the domain, remember in maths, when I speak about the domain, it's all possible values of x. Range is all possible values of y. That's why I said you can't be able to answer this graph, these questions if you didn't draw the graph. That's why when we trace this, there's a reason whereby the first question I said, let us draw the graph. Because the way they're going to ask you this in an exam, they are either going to draw the graph for you. On about, they will say draw the graph and write the period, amplitude, or domain. Or you find the graph being drawn and then they give you unknowns in this regard. They can just say y is equals to, they say sine of bracket theta, and then about t minus p. And then they draw the graph for you. That's another approach, that's another concept. And then they say find the value of p. That's the last part of the trigonometric graphs that I'm going to teach you. Now, I taught you the basic graph of a sine graph, of a cos graph. Now I'm showing you the different concept. And then I didn't teach you how to get the value of p. I didn't teach you how to get the value of q. Why? Because I can't teach you that now if you don't know how to draw the graphs. If you don't know how to apply the graphs. If you don't know how to interpret the graph. You get to see that. So, for you to be able to know those, that is the last part of trigonometry. That's why myself, you will never say you didn't teach me. Unless if maybe I didn't teach you like that. That's why you can try to wait the way I'm teaching. And some might say, hey, we spent a lot of time with regards to trigonometry part. But some of you, maybe you actually said, we are done with trigonometry. But now you're getting enlightened to say, hey, seems like it's a new information to you. You know why? Because there's still a lot of things that they will be asked. So the way I teach maths, I teach you all the angles so that whenever you see a question in this form, you know how to basically solve that. So I think I'm loud and clear with regards to that. So when I talk about the domain, it will be what? X is an element of what? X is an element of, remember, I told you in the previous sessions to say, when you know your graph, ukuthi iqala kuphi, iphelela kuphi, then you use braces, big braces. If you don't know where your graph started or where it ended, you use small brackets. With regards to the brown graph, if you check it properly, we know that it started at minus 360. So I'm going to use brace. Then write minus 360 just like that. Comma. Then I know that the brown graph, it ends at 360. Then I'm going to say 360. Then you must write 360 degrees again. And then write big braces with regards to that. And then with regards to this one, which is what? The green graph as well. It's x is an element of what? X is an element of brace because we know that it starts at what? We know that it starts at negative 360. You write negative 360. We know that it ends at 360. You write 360 degrees. And then you write another brace here. You must write number braces on both ends. If you're going to use small brackets, you'll be wrong. Even if you included 360 and 360, you'll be wrong. And then on number 4, we are done with regards to that. Now I think you are getting to understand this base because of I'm showing you in different angles. So on number 4, what are we basically looking at? Finding the range. So when I speak about the range in maths is all possible values of y. So the range of both graphs, it will be y is an element of, just because of, you know, ukuthi graph yakho from what? Iqale from -1 to 1. You'll write -1. There's someone who's moving that. There's someone who's moving my screen, who's writing something. It's -1. And then just because of, you know, that it ends at 1, you're going to write 1 like that. And then that is why it's an element of brace, because you know ukuthi graph yakho iqale from -1, then it ends at 1. Those are some of the things that you must know from here. Done with that, moving, you see? So if you say now you know trigonometry, I think we must be speaking the same language now. If you don't still understand me, I'll encourage you to keep practicing because there's still a room for more, right? And then number 5, we are now looking at finding our minimum turning points. Minimum TP. So when I'm saying TP, it simply represents turning point. So what will be our minimum turning points? So with regards to the original graph, which is the brown graph, minimum turning point, it will be minus 90 degrees. And what? These ones, they don't need more clarity. Minimum turning point, minus 90 and negative 1. Right? And what? I think this one makes much more sense. And 270 degrees. And what? And the negative 1. Remember, I said with regards to using our turning point, a turning point, remember, it's in a coordinate form. Bracket X and Y. So here you are not applying that concept to say, you know, the graph started here, you know, the graph ended here. Here, it's a matter of you applying the concept of knowing how to write the coordinate that is represented by X and Y, just like that. And then the minimum turning point of the green graph that is represented by y equals to sine of theta minus 30 degrees, it will be what? The minimum turning point. It will be minus 60 degrees and what? Minus 60 degrees and negative 1. And what? Followed by 300 degrees and negative 1. 300 degrees and negative 1. So those two are the ones which are going to represent our minimum turning point. Lastly, maximum turning point, and then we want the x and the y intercept, then we'll be done with regards to this. So it means to say, when I extend my table, so now we're finding the maximum turning point. Maximum TP, which represents the turning point. So the maximum turning point, it will be what? It will be negative 270 and 1. Negative 270 degrees and 1, right? As well as what? And 90 and 1. And 90 degrees and 1. So that will be our maximum turning point. Maximum turning point for the original graph. Then the other maximum turning point here is going to be minus 240 degrees. And 1. And 120 degrees and 1. 120 degrees and 1. Remember, when we speak about the turning point on the graph, that's where the graph actually changes its direction, right? And then one thing that you must also understand, you must make sure, the reason why I'm showing you this, someone might think, I'm wasting time. I'm not wasting time. You know me doing a table like this where it says an amplitude, domain, range, turning point, maximum, and minimum turning point, as well as x-intercept and y-intercept. I will have actually answered a lot of things with regards to trigonometric graphs. Because in a table form like this one, if they ask you a question, they say find the range, you know how to find the range. If they say find the amplitude, you have an understanding with what will be the amplitude, right? Number 7, we are now speaking about what? My x-intercepts. X-intercepts. So when I speak about x-intercept in maths, x-intercept is a point on the graph where the graph passes on the what? Where the graph passes on the x-axis. X-intercept, it's a point on the graph where the graph passes on the what? On the x-axis. So with regards to this one, it's saving a lot of my x-intercept. That's negative 360 degrees and what? And 0. Followed by what? Followed by negative 180 degrees and 0. I want to show you something. Degrees and 0. And what? Followed by 0 and 0. 0 and 0. Followed by 180 and 0. 180 degrees and 0. Followed by what? Followed by 360 and 0. I want to show you something. 360 degrees and 0. Remember, when you speak about x-intercept, it's a point on the graph when the graph passes on the x-axis. And remember, when you say x-intercept, you say let y equals to 0. That's why when you look at all the y values here, you are getting 0 or you are seeing 0. You must not be confused. And then with regards to the y okay, with regards to the y-axis, it will be the other way around. Y-intercept, let the x is equals to 0. Do you get to see that? So now let's write let's write our x-intercept of this green graph. That's going to be minus 330 and 0. Minus 330 degrees and 0. That will be minus 150 degrees and 0. 0. That will be what? 30 degrees and 0. 30 degrees and 0. Lastly, that will be what? 210 degrees and 0. 210, please write it properly. And 0. Do you get to see that? And then lastly, now I'm looking at writing my y-intercept in this 2 minutes left. So that's number 8. Please write it properly, y-intercept. Remember, y-intercepts, it's a point on the graph where the graph passes on the y-axis. And whenever we want our y-intercept, we just say let x is equals to 0. Solve for y. It means to say here, you must always expect all the x values being what? 0. So our y-intercept here is only 1, which is what? 0 and 0. And then this one, it will be 0 degrees as well as what? As well as negative half. Because if you remember, there is somewhere where I drew the green graph and I was speaking half where the graph passes in between. If you didn't understand, let me go back again. So check the green graph. Somewhere, somehow, in most instances, those points they were moving in the middle. Look at this point right here. It's moving in the middle. It's moving in the middle, half between 0 and 1. Look at that point here. It's in the middle. This point is in the middle. Just like that, you see. So it's not difficult. You just need you to put your mind on it, focus on it, practice a lot, and then the rest is history. So that's how we conclude today's session. We'll meet in the evening with the last session. Any question?